Memory alignment plays an important role in languages like C, C++, or any kind of languages that deal with low level systems programming. Okay, so the idea of memory alignment stems from the way how our CPU fetches data from RAM or cache. Okay, so what happens is like the CPU doesn't actually fetch the data from this RAM or like any kind of cache lines byte by byte. It grabs it in form of fixed chunks, or you could call it buckets. Okay, so these buckets could be of the size 4 bytes, 8 bytes, or even 64 bytes at a time. Okay, depending upon how aligned your operation is basically. Okay, so that is basically an alignment, the bucket or the scoop that you have. So in a single scoop you can fetch a lot of data. So what happens is like if you have an 8 byte double that your CPU wants to grab in a single scoop, for that it must have an address that is a multiple of 8. In that sense it is perfectly aligned. The CPU is happy and it will be fast and the data will be fetched properly. What happens is like if your struct is not properly aligned, okay, so I will give you an example code also of what is a properly aligned struct and misaligned struct. So if you do not have the memory in what you call a multiple of 8s in this case, then what happens is like CPU has to perform 2 memory fetches. Okay, so which is again inefficient. Okay, so it has to do 2 memory fetches and shift the bits, stitch them together. Okay, so that is like for every single variable you would be doing twice the work. Okay, so what happens is like compilers, modern day compilers, want to make the task easy for the CPU. For that purpose they do something like they add a padding value. Okay, empty wasted bytes to force your data to line up. Okay, so to give you a context, these are the two structs that we are looking at, the good struct and the bad struct. So in the bad struct what you say is a character A, okay, which is 1 byte and it is padded with 7 bytes. Okay, then you have a double which is 8 bytes. So here how exactly the alignment is decided? The context is of this thing is, the idea of this thing is basically the biggest data type. Okay, the biggest data type in this struct will be the one according to which the alignment will take place. So overall in this struct, if you see, there are a lot of chars or characters and double. So double is 8 bytes, so this whole thing is 8 byte aligned. Okay, so what happens is like character is only 1 byte, so 7 other bytes are padded. So what happens is like for this bad struct, to worsen the matter, this whole thing reaches a size that is more than 64 bytes and the cache lines are of 64 bytes. Okay, in modern day CPUs as well. So what happens is like anyways it has to do 2 cache line fetches, because in a single cache line fetch it doesn't have it all the data and it is a wasteful space. So below you can see the same amount of variables, okay, in a properly aligned way. So all the doubles are at the forefront and at the end you have this tail padding added by the compiler. Okay, so here there is no extra wastage of space. You got my point? So this is how you can distinguish between a good struct and a bad struct. Okay, and now we'll run this thing. So after we run this thing, we'll see how and what difference we get. Okay, to run this thing, okay, so we have already compiled this thing. Okay, this program is already written. Okay, we have seen the struct, like I showed you the same struct, and here we have simply written a function, okay, a template function which takes like 10 million iterations of this thing, of this struct, and does the summation of d1 and d5 within this struct. Okay, and that is done over here simply, and after that summation we show in the main, we return the benchmark. Okay, and those benchmarks difference between the times we have taken over here, and the whole operation that we have seen will be in microseconds, the differences. Okay, so let's just run this thing. So we'll have to run this thing multiple times. Okay, so we need to be careful of that, because for running this experiment we need our cache lines warmed up a bit. So you might get a range of values ranging from certain microseconds to higher microsecond values, like 1000 microseconds to a 4000 microseconds or 5000 microseconds difference. So that we'll have to test it out. Okay, so we'll just increase the size of this window and we'll start running. So see here, important thing, size of the batch struct, like we said, it will give the size of is 80 bytes. Okay, same number of variables it has, same number of characters and same number of doubles, still it is taking 80 bytes, and the good struct is taking 48 bytes only. So alignment in terms of space is also important, because your cache lines are exceeded, like 64 bytes of cache lines we have, and that is exceeded, so you need 2 accesses anyway for the batch struct. And see here the timings for the batch struct, it took 187768 microseconds, and for the good struct it took 143703. so like the difference was like 44 microseconds. Okay, so 44,000 microseconds. Okay, so we'll run this again. Okay, so see here, again this is giving you the difference in microseconds. So here it took slightly lesser. We'll run it again. Okay, again and again we can run it, and after like 3-4 iterations we will get a stable reading, somewhere along the median reading we will get. Okay, so that is the actual execution time which might take. Okay, because this is not like RTOS or that sort of a thing, so you will not get a fixed value, like fixed value, a precise value will be not there for the differences in the execution times. But to prove the point, always the good struct is taking less time than the bad struct. Okay, so that was the point of this experiment. So what you need to know is, whenever you're designing your structs or like your data structures, whenever you're doing, design it in such a way that your structs are properly aligned. Okay, and if you use something like padding or that sort of a thing, like people use like to align this thing, they use pack or different types of operations are there. So we'll not cover this in this video, but if you use any of those operations, then you need to be careful, because what happens is, like when you use packing, anyway you will require like extra cycle for that. Okay, so that we'll discuss in some other video. So hopefully this video was helpful for you guys who are not aware of the alignment process. Okay, and you will be careful the next time you will be doing this, hopefully. Yeah, thank you.